this is, once again, we saw all the pictures of excess water. Through 2010 to 2014, we were averaging about 40 inches of rain, and that was coming through May and June. So it was really fun farming those years. And so this is what my grazing cornfield looked like. Kind of tough to get anything in the ground, but and once again, water infiltration, all this other good stuff. This event, those 4 years, actually promoted my soil health. It accelerated what I was doing, because we couldn't get on to the ground in a lot of cases until July, and neighbors were going out and they were chem following, and they were just dealing with the excess water by not doing anything. Where I was going out and seeding cover crops. So this is where I started seeing some huge advances in my soil health, even though we had to really take a beating on the rest of what we're doing. So our water cycle, once again, great job throughout the day talking about the water cycle, how water comes through. But basically, we have precipitation, we have water or soil. Water infiltration into the soil, we have that plant use, we have soil percolation, we have runoff, we have evaporation, we have transpiration. And one of the things that Dr. Dwayne Beck talks about is, in agriculture, to build soil, we have to take the E out of ET. That's evaporation from evaporation transpiration. We need to be transpiring water. And the whole idea with the trees, with the perennials, with all of that stuff. When we are using water and putting it through a plant, that plant is going to be putting through and releasing back into the soil root exudates. We have root exudates, it means we're feeding the soil biology. That biology needs air, needs water, needs food, needs shelter. Now we're starting to build soils. And so water is, once again, I've been coming up with, I was trying to figure out the first time I came up to the piece, and I think it was about back in my CCAN days, way back in 98, I started coming up, 97. But when I was talking soil health, it was about 2010. And, all through my experiences up here, we'd always hear about, on one side of the piece, we got drowned out, on the other side, we're flooded out. So there's all of this differentiation, and the other joke in Saskatchewan is, that last rain we got, well, that means we're only 6 weeks away from the next drought. Is that going to be the last one we get? So that water cycle is, we're always looking at the sky. We're looking for rain. Is it going to rain? Is it going to stop raining? The joke in the city is we're a bunch of complainers because we're never happy with the moisture. Well, guess what? We don't get that half an inch of rain every 10 days that we had ordered. So that's what we're hoping for. So what we want to do is, manage this water cycle. And so if you do some Googling and look up Walter Yene out of Australia, he does a lot of work about this micro water cycle. And when I was over there, when I spent time in Australia, basically they have 5 months where they get rain, and then they get 7 months where it doesn't rain normally, it doesn't rain very much. So when we are looking at those, fragile areas and those fragile times that we go through, because we go through those dry spells, how do we do it? How do we manage it? How do we attract water? How do we retain water? How do we infiltrate water? How do we store water? And that's the challenge that we have when we go through and developing systems. So when you're talking about cover crops and you're getting to the aggregation and things seem to magically start working, most of the time it's going because we start fixing this micro water cycle that we have. And it isn't, that little storm clouds coming through, we have that cold front and we get the thunderstorms. We're talking within the square yard. We're talking right here when we're talking micro water cycles. Bare soil creates drought. Having no living plants creates drought, because of the whole fact of that the plants, the green plants, throw up those rain nuclei that creates these rains. when I was over in Australia, I spent time with Di and Ian Haggerty. If you don't know who they are, they're the largest regenerative farm in the world. They're at 65,000 acres, 35,000 acres of cropland, where they haven't used any fertilizer. They use minimal herbicides. Very, very strong biological program. And what they've done is they've acquired a block of land that runs northwest, southeast. And what they've done is they started a tree project on the northwest corner of it. Their jet stream comes northwest to southeast, kind of like here. What they're finding after 10 years of that, having these trees established, they're actually starting to see more rain in that strip where that jet stream comes that goes over top of those trees. So we are seeing some, by revegetating the soil, we're seeing some differences. So, this is what we have to look at is, okay, so how do we manage, how do we influence the moisture that we have in our soils? And basically, when we look at this, water follows carbon. Whether you believe in climate change or the carbon programs out there, water follows carbon. So in the atmosphere, we are seeing increased carbon levels. What else is happening? Water follows carbon. So we get more humidity in the air, and the number one greenhouse gas in my mind is water. Anybody here mad at water? Unless you're getting too much or not enough. Who can get mad at water? We need water. There's bottles of water here. There's, everybody's drink. We need water, right? Carbon we can get mad at. It's the villain. But in reality, we put more carbon into our soil in the form of organic matter, we're going to store more water. And that 1% organic matter is storing 27,000 gallons. And once again, I'm not very smart. So I had to figure out, what does 27,000 gallons water look like? And it worked out to 1 inch of rain. So those numbers that you're throwing around, you're bang on with those numbers. So if we can do this and build our soil organic matter in the soil, drive that A horizon down, then we start winning. Because the more of this A horizon that we have, that's a biological active area in our soils. When I first started, when I bought the dirt, and it was dirt, believe me, the guy would grow wheat, bale the straw, then burn the stubble. Then you'd grow barley, bale the straw, burn the stubble, and then black summerfall it. So I had dirt. It was a loamy sand, and it was just horrible. But by going through the soil health principles, we can start getting carbon in the ground. We can start affecting what happens in their soil. So when I first started farmed with my dad, my soil, my land, couldn't touch his yields. After 5 years, we're getting about the same yield. And at the last one, before Dad started doing the soil health principles in his land, I was out yielding them with diddly for using any synthetics. So soil carbon, when we start increasing our soil carbon in the soil, we're going to increase our water infiltration. That's usually one of the things that you start noticing. We start seeing increased soil aggregate stability. Anybody here testing your soil aggregate stability in the soils? It's one of the really easy ways of testing your soil health if you're moving the right direction. And what you're going to end up finding is if you're adding the soil health principles onto your land, this may be the easiest thing to see changes, positive changes. When we increase the carbon in the soil, especially when we're talking liquid carbon, we're going to be increasing the microbial population in that soil. If we keep putting that liquid carbon back into that soil, we're going to store that more water, and we're going to decrease the bulk density. Is that, anybody have an idea why bulk density when we start decreasing our bulk density? Yep. Porosity. When you have porosity, you have more air, you have more rooting ability. When we're looking at our soils, it should be 50% pore space. which sounds really goofy because when you get this fatso walking across it, if it has 50% porosity, I'd fall right through, right? Potentially, maybe that's quicksand, but when we start looking at this function, this porosity is huge. We need those roots to be able to go in anywhere they need to. So when you see something like this, where you see that chocolate cake appearance, that means that our roots, our earthworms, they can go anywhere they want, basically. Yeah. Liquid carbon. Very much like water. So very good question. So liquid carbon, so what is photosynthesis? What is the reaction for photosynthesis? Water plus carbon dioxide producing C6H12O6, which is sucrose. That gets released as a root exudate into the soil, and that, when it's released as a root exudate, it's combined with water, so then it's water plus this sugar. So it's sugar water is the basis of the root exudates, plus there's going to be oils, there's going to be proteins, but that liquid carbon, so when you're looking at oils, when you're looking at protein, that's still carbon-based. So it's going to be released from the plant into the soil via water. Okay, good question. So how do we increase our soil water, or soil moisture? So we want to increase our water infiltration. We want to reduce our evaporation. We want to cycle soil moisture better. We want to maintain armor. We want to reduce compaction. We want to increase organic matter. So apologize for the people at the back, but this is a video from Western Australia. They have something called non-wetting sands. So this sand you pick up and it runs through your finger, but when you add water to it, it will not go into the soil. It will sit there. It will evaporate before it will go into the soil. And we're talking 95% sand, 1% organic matter, and you cannot get any water into that soil unless there's a plant there. Then the water will fall the plant down. How's that for a challenge? Low organic matter, high sand, and you can't get water into it. So they got some issues. So when we're looking at this, how do we get more water infiltrated? How do we reduce compaction? How do we do all of these things? This is the soil health principles that we go through. And so how is a grain farm going to do it versus an organic farm versus a cattle farm versus a mix? Everybody's going to have their own little ways of getting it done. Are we dealing with sand? Are we dealing with or clays? The problems with clays, like once again, easiest way to start building soil aggregates is in clay, but it's really hard to get these roots into the soil when we don't have that soil chemistry balanced. So this is one of the examples that we did a couple of years ago. So on the left is a field of that we've done regenerative principles, no synthetics for, 10 years. And it was soybeans, harvest of grain. Then we seeded a full season cover crop, underseeded to perennial ryegrass. Over here is where Dad said, okay, that's where we're driving in and out of the lane, or out of the yard, so we're going to keep it black and summer followed. So this is called a slake test. So on here, this is where no till, lots of plant diversity. Over here is where the tillage has happened. My dad said, but we have to till the land because we have to get the water infiltrated. That's how we infiltrate it. And he's right, when you're dealing with bacterial dominated soils. What we want is over here. Stable. Anything falling down, big clumps. Those are microaggregates. That's, that is still adding stability. I could drink the water here, over here. No. So right away I'm going to look at the top. There we go, right on cue. And you'll see these sloughs. So when you see a slough, water in the spring, and it's nice and clear, that means you have decent aggregates. When we see this slime on top, that's carbon. So what'll happen in this slake test, so when we're dealing with this bacterial soil on the right, so these particles, these macroaggregates that we have, I've air dried them, so they're super dry, put them in this mesh, put it into the water. When it is bone dry, the water rushes in. The air, and it's rushing in from all sides. When it's rushing in from all sides, this air is trapped inside that aggregate, and so it's trying to get out. If it has this glomalin in it, which is a soil aggregate stabilizer, the air can go through that and gas off. If you don't, there's little explosions basically of that air trying to get out, and you get this. So the idea of hydrophobic soils is basically highly bacterial soils. When we start building active fungi in the soil, we start getting this. So that if anybody in the room, if you're looking at getting into regen ag, or you feel that you've come into a bit of a bottleneck why we're not moving ahead, first question that Christine Jones asked me was, do you use any fungicide? If you're using fungicide, stop. That's the first thing. Number two, keep a living root in the soil. And so as we go through, I'm going to do the summary of my soil health principles at the end, but these are the things we really need to do. That vegetative plant is crucial for building soil stability in our system. So reduce tillage, that's number one. And so someone asked me, he said, okay, so what's my definition of reduced tillage? Timing is number one. Jill Clapperton, she told me never till in the fall. Because once again, the whole concept of tillage, of minimizing damage is, okay, so when you do tillage, what are you doing after? And Christine Jones, if you listen to John Kempf and Rick Clark's podcast that they did, and they talked about the visit with Christine Jones, Christine Jones said that Rick Clark can work down 6 inches, no problem in the soil. And I lost more hair. Because I thought these people down in Seven Persons and Assiniboia, they're going to say, well, Christine Jones says I can work 6 inches deep in my soil. Later in the podcast, they said, yes, they have 40 inches of A horizon, so they can work down 6 inches, which percentage-wise is 15%. So if your A horizon is 10 inches deep, you can work down about 1.5 inches and not do a lot of damage, assuming you're putting more carbon down after you do your tillage. So it isn't the tillage disturbance per se, it's what are you doing after. So doing it in the fall, and you're not putting down any seed, you're not putting down any biologicals, now that soil has 6 months where it can't recover. You do it in the spring, and you're putting down seed, or you're putting down, alfalfa pellets, you're putting down carbon back into the soil, now that soil can repair quickly. So that's part of the challenge of reducing tillage. It's not necessarily the active tillage per se, but what are you doing after? Letting it recover. Keeping a vegetative plant growing, especially in the fall. Most agronomists, especially sales agronomists, hate that line because that's stealing yield. We'll get into that in a little bit. Reduce reliance on synthetic inputs. Maintain your soil armor, increase the functional plant group. So this is a picture of the compost extract that Haggerty's do. Nothing really high tech, but they can do it on acres. What we need to do to stabilize these soil aggregates is have this diverse active microbial activity in our soil. This is where, I wasn't sure where compost and the compost extracts fit in. The compost part of it, especially if you have significant acres, you need a lot of it to make it work. This compost extract works really nice. Really simple. You can really do it on scale. When we add this diversity, we need to feed it. And what does the microbes need to eat? Liquid carbon. Where does liquid carbon come from? Photosynthesis, root exudate. We need to have those root exudates. When anybody here have cows we can feed for 30 days of the year and then not feed them? They don't eat anything for the rest of the year? Anybody? That's where I like them, but that's besides the point. we need to feed our soil biology. When we're growing annual crops, so if we're growing an oat crop, Omex had a great management system where they talked about the first 30 days, the next 30 days, the last 30 days. So working on 90 days for maturity, pretty close. First 30 days, the plant's in the vegetative stage, it's releasing root exudates. When the plant starts putting up a stem, the root exudates drop off dramatically because that plant needs all that carbon to produce that plant, the stems, the leaves, the above ground. So when we're growing these annual crops, we only feed the soil for 30 days. That's why we need, the whole idea of putting in Italian ryegrass in with your cereals, putting in some winter cereals in with your spring cereals. We need that living root with those root exudates. John Kempf, if you read his book and follow some of the stuff that he talks about, the highest ROI you can get from any input is a biological right on the seed or in the seed trench. Highest ROI. With EcoT, they did some work outside of Saskatoon at Discovery Farms, and one of the things that they were looking at is, once again, apologize if, did you have any brochure, those printed out here? Okay, so the reports are up here if anybody's interested in looking. So this first line in here, it shows, this will improve water infiltration. So this first one is the grower standard. The next one is using the compost and the compost extract in furrow with half of the fertilizer. And you can see how much more, what an increase in your water infiltration. Our fertilizer program, especially nitrogen, is extremely flawed for soil health. Because when we over-apply nitrogen, the soil microbes, they have this free nitrogen in the soil, and if we don't have enough root exudate to balance that nitrogen, our microbes, if they can't get the carbon from the plants, they're going to start eating our organic matter. That's part of the reason why we get this compaction problem. This is why we get weeds. This is why we get all these different issues in our soils. So we need to really manage, and it doesn't matter if we're talking organic or conventional, over-application of nitrogen is one of our huge problems in agriculture. It triggers our weeds, it triggers disease, and it triggers our bugs. So there's some issues there. So our water infiltration, maintain our soil armor. Keep that armor on top. When we get into biological systems, I was talking to Chris Nichols and I said, I can't keep enough straw on my soil surface. I'm growing triticale that's shoulder high. We're combining it. We're spreading the straw back on the surface. And by the middle of June, it is gone. What do I do? She said, well, okay, what are you doing in May and June before it disappears? I said, well, I'm seeding a cover crop. She said, don't worry about it. Green cover versus brown cover, that's okay. So green and brown cover, once again, as we go through it, another quote from Christine Jones, whatever is good for the rumen is good for the soil, and vice versa. So if you're feeding your animals nice green meadow brome that's this high and just lush and growing, what's that manure like? A little runny, isn't it? If Bessie has a cough, make sure you're looking at her eyes. If you're running out of feed and you're just feeding straw, what's the manure like? Big pile. It's hard. Guess what? The soil's going to react the same way. So we have to have that mixture of green and brown going back into the ground. Dr. Muir, he's a humate expert. And so one of the things that he said was never bale straw unless you're planning on returning it back to the field. And when I go through central Alberta, as soon as that combine isn't even out of the field and the baler's in there and getting rid of that straw. It's a huge resource that we're losing. We need to have taproots in a rotation. And once again, we'll get into that a little bit more, but having these taproots, having the mycorrhizal plants, really crucial on getting our water cycles going. We need to build that earthworm population. And this is when I first started doing my talks up here. So I've got chewed out by 2 or 3 people saying, I hate earthworms, they make my ground hard. So got on the phone, Dr. Jill Clapperton, and said, I'm up here and I'm getting chewed out. Why? What's missing? She said, what was the rotation? Oh, peas and canola. I said, how much carbon's going back into that soil? Thank you. So if you're getting hard soils, more living roots. There's some plants that we have access to as a cover crop, and we can intercrop and polycrop, multi-species crop, that accumulate calcium and phosphate. These forbs are one of the missing functions we have in our rotation. We want to manage our compaction. Last year, having Dr. Menard, great presentation on managing compaction. You know, the whole saving grace of using tracks to save compaction. Boom, no, they actually create more compaction. So, you know, watching your wheel weights, watching your tire inflation, all this good stuff that you go through the history of the last year's presentation. Some really good gold in there. And so just as we mentioned earlier, we need to have infiltration across our landscape. Our hilltops, our mid-slopes, our toe slopes, our lowland. Instead of having these hard soils and the water runs right from that hilltop and it runs into the slough, and now you're going to have sitting water in that low spot. And so one of the things that we worked with Paul Canuglian up at Birch Hills, on his home quarter, he was seeding 54 acres. So it was a little bit potholy, a little wet. So we started getting some taproots in, we got some sweet clover, we got some chicory, got some biennials into the mix. After 3 years, he was seeding 156 acres with the same rainfall. There's an organic producer just outside of Edmonton. You know, I got him away from the reliance on tillage. We got these taproots in, we got living root. His dad said to him, I've never seeded this slough. We had more snow than normal, we've got more rain, but now we're seeding right through the slough. What's going on? We've started fixing that water cycle. We got the infiltration. We got a living soil again. And so this is a soil pit that we dug, and so this is a straight alfalfa field, a little bit of grass in it, and you can see all the taproots going down. That was down to 4 feet. We need those taproots, and it doesn't have to be a pure stand of alfalfa. I'm talking and working with organic producers where we'll put down 0.05 pounds of alfalfa in with their wheat, with their oats, with their barley, just to have one alfalfa plant per square meter. They're swathing anyways. And so if you're swathing, well, what's the opportunity of putting a little bit of an end fixer that's a mycorrhizal that has deep taproots to help build that soil for yourself? We need to build those soil aggregates. And how do we build soil aggregates? Living roots of a plant in the vegetative stage. We're pumping liquid carbon into our system. That green plant, you know, that high root exudate, it's going to support more microbes. Within a microbe, how much moisture is in a microbe? And once again, where's Kim? She hangs around with Chris. How much moisture is in our soil that's tied up in microbes? So if we have 2 steers and there's 70% moisture, that's a lot of moisture. And that's just in the microbes. So once again, as our natural system rolls through and we start getting dry, those microbes start going dormant. They start dehydrating to release moisture into that system to give us the hope to keep us going until we get that next rain. How's that for wacky natural intelligence? When having that green plant in the soil, it's going to cycle our nutrients for us. So when I see a soil test, and you know the soil test we looked at, when I was seeing some of the nitrate levels, the only reason I look at nitrate in a soil test is to see how broken your system is. So there was a soil test with a little bit of manure in that with 156 parts per million or pounds of nitrogen. That tells me that system really needs some balancing. So when we have that green plant in there, it's going to soak up that free nitrate, because nitrate in our system is a toxin. It hurts our microbes. So our plants will passively take it up in our soil moisture and utilize it. And this is part of the reason why we have to desiccate our crops. We have too much nitrates in because they keep soaking up water when they're supposed to be shutting down and maturing. Too much free nitrate in our plants. So that when we go through and we have this green plant growing, it's going to soak up that nitrate, it's going to convert it over to an amino acid or protein and other nitrogen-containing compounds. It's going to get 20% protein or whatever the magic number for that species is, and then it starts releasing it back in the soil, because why do I have so much nitrogen and protein in my system? And I'll keep absorbing this nitrate. In order to convert nitrate into amino acid, it takes 5 steps. Really energy intensive. So do you want your crop to be doing that, or do you want this Italian ryegrass or winter triticale or some biennial crop underneath doing the heavy lifting, releasing that complex nitrogen compound into the soil so that plant can take it up and go straight to amino acid or protein? What a beautiful system. But because of our system growing monocrops, we're not getting that. One of the things that Jimmy Emmons, if another great guy to search, Jimmy was doing some cover cropping in Oklahoma and had half an acre and ran out of seed. He said, what a great place to do a check strip. So he got 2 soil scientists come out, and he said, okay, we're going to do some testing in the fall. And they went down a foot, and they said, the cover crop, it dried out the land. Where you didn't have the cover crop, you have twice the amount of moisture. He said, okay, that's nice, but that's a foot. How deep are the roots? So they started digging, the roots were down 4 feet. So they said, okay, we're going to do a test. We're going to do a core down 4 feet. We're going to check the moisture there. Where they didn't have a cover crop, yes, the top foot had more moisture, but that's as deep as that water went. Where the cover crop was, the moisture followed the roots down, and it turned out that it had double the amount of moisture where the cover crop was as compared to not. Never mind, no weeds. Organic producer at Spalding put a pound of Italian ryegrass in with his oats, as I recommended for him. He said it was a dry summer. His oats, where he had the Italian ryegrass, was about 3 bushels less than where he didn't, but his weed pressure dropped by 80% organically. So once again, another win for these living roots. The other really interesting thing with these green plants, if there's a producer down south of Swift Current, so a little on the dry side, I told him put 20 pounds of winter triticale in with his durum. So, okay, did it. His neighbor had an agronomist, did everything BMPs, did it by the book. Neighbor's durum was about this high. They had about between 4 and 5 inches of rain, so it was really dry. So durum was about this high, didn't yield very well. The guy with winter triticale was waist-high durum, right across the road. Neighbor said, well, that's easy to explain. Rain stopped right at the road. The whole idea of having that green plant underneath your cereal, not only is it cycling nutrients and it's tying up nitrates and suppressing weeds, that green leaf is going to cool down quicker than the air. When it cools down quicker than the air, and there's any moisture in the air, it's going to condense on that leaf. If the plant is under some drought stress, it can absorb that through the leaf and use it, catch sunlight, photosynthesize, releasing root exudate, some liquid carbon into the soil, so getting that water from the air, through the leaf, through the root, into the soil. If the plant has enough moisture, it's just going to ball up on the leaf, and it's going to roll off and land on the soil, which then infiltrates. Hopefully we have infiltration. And now the microbes can use it, the plants, our cash crop can use it. We're starting to address our microwater cycle. So the other thing is, I have some thermometer pictures. It's been a long day. Of where we have green cover over the ground versus black. There's huge differences in temperatures. So it's keeping that ground cool. We want to get into this multi-species cropping, and especially when we start using mycorrhizal friendly plants growing together. We want to have that deep taproot growing with a fibrous root system. This, especially from different functional plant groups. If we have that legume, now we have our end source. We have mycorrhizae. We have that good synergies happening. And once again, we have to really work on what rates we're putting it down. What is the goals? This is down near Moose Jaw, chickpeas and flax, organic. Put some Italian ryegrass in there, and the guy said his wild mustard problem disappeared. But what they found in, and once again, what university was it? Was Iowa or Illinois? They had some towers of soil, and they were growing chickpeas and wheat together. And they had 2 towers. The one tower, they had them growing together happily. The other one, they had a plastic divider between the 2 plants. They induced drought stress on the plants. The one with the divider, the chickpeas survived because it was able to get down into the water, but the wheat died. Where there was no divider, the wheat lived. When we deal with these polycropping, these multi-species cropping, it turns very socialist. It wants everybody to win. So when we have these mycorrhizae plants, taproots, living roots, this is how we start cycling that water within our system. This is a new little project that we're hoping to launch in the next little while. This is a virtual cover crop blend simulator. So we can put in what species at what density that we have in our mix, and it will show you the potential growth above ground and the root systems below it. So that this way we can go through and we can see which one do we need for our soils. What do adding a certain species do to our rooting depth? What system do they have? How much potential top growth do they have? All of these questions are going to be a lot more visible when we're doing our management. So when we're looking at our soil health principles, maintain that living root for as many days possible. Chris Nichols suggests that we should be about 250 to 260 days of having a green plant in our soil. Which once again doesn't make sense because we only have 90 to 100 frost-free days. Like this, yeah. I saw the nice lady standing, so I was checking to see where I'm at, and I should be good. So we need to have that green plant. So if you push back the snow and the snow starts melting, do we have a green plant poking through? Or did we have one a month ago? That's even a better question, because once again, if we have it winter kill, that's easy and cheap to get rid of. We want to increase the functional plant family diversity that we're growing. Grasses, legumes, brassicas, non-brassicas, and forbs. Ideally, we should have less than 5% of our plants being brassicas. We want to reduce the reliance on synthetic inputs, rely more on biological, way more stable, way more economical. We want to reduce the amount of tillage we do. We want to properly incorporate livestock. And once again, some great examples today of how we can do that. This is a picture comparing 2 systems. This is from a young lady from New South Wales, Australia. So over here was phosphate fertilizer. Over here was a biological seed dressing. No fertilizer. Dry year, they planned on doing some grazing. This died. They didn't get any grazing. This one they ended up getting 3 grazings out of. Because we had biological system on the seed. So there's my contact information. Feel free to reach out if you have any questions or